What is a solution? Well, a solution is just a type of mixture. So there's all sorts of types of mixtures we can look at. There are suspensions where we can actually see the particles. There's colloids where the particles are super tiny, so we really don't see them terribly well, but you can tell that they're there. And then there's true solutions. True solutions are heterogeneous mixtures where we can't actually see any of the individual particles apart from each other. So you can see on this slide, I've got a few different examples here where on the bottom I have those little square vials, and you can see the ones with teeny tiny particles, you can't tell anything apart. But as we get bigger and bigger particles, you can start to see the solution gets really cloudy. And then you can see the, if you have the slides downloaded, I couldn't get the picture to fit quite right for my little head thing here. But the true solution to these other square ones, when a light is shined through, the beam just goes through. But in a colloidal type of situation, you can see the scattering of light. So you can tell that the particles are actually there. They're big enough that they'll scatter light. Okay. So what is a colloid? Just so you understand the difference between a colloid and a solution, because again, when we look at our solutions versus our colloids, you can see little particles. So like an aerosol, that's a colloid. So fog, so you can see, the foggy stuff. Smoke, okay, you can see the particles. Emulsions, things like mayonnaise. If you didn't have an emulsifier in there, they actually separate out into their individual parts. Whipped cream, this is a type of a solution. So this is gas in a liquid, which is why if you let whipped cream sit for a while, it eventually deflates and collapses. And then there's a picture on here too that of an opal. Opals are really pretty. That's actually a liquid in a solid. Okay, but a true solution is a homogeneous mixture. And so we have a solute and a solvent. So our solute is what gets dissolved. Our solvent is what does the dissolving. All right, and so again, we just say that solution, solute dissolved in a solvent, it's homogeneous. You can't tell the different pieces apart. Solvents are typically present in a greater quantity and it does the dissolving. Solutes are present in lesser quantity and they are what is dissolved. When we prepare a solution, when we need to have a known concentration, we'll weigh out what we need. We'll add some of our solvent, we'll get it to dissolve, and then we'll continue adding solvent up until the point at which we get to wherever the mark on our piece of glassware is, whether it's a volumetric flask like shown here, or a graduated cylinder, or whatever we're using to make our solution. So we have different types of solutions. We can get gas and gas. We can get liquid dissolved into a gas. Liquids, we get gas dissolved in a liquid, liquid dissolved in a liquid, solid dissolved in a liquid. And then we can get solid solutions where we have a liquid dissolved in a solid, or we have a solid that's mixed in a solid. A lot of solid solutions though, you end up liquefying things first, getting them to mix, and then you let them re-solidify, and now you have your solution of different solids. All right, and then we have different limits of solubility. Certain things will dissolve tons in a given solvent. Other things don't dissolve so much. So water is a really, really good solvent, but not everything is soluble in water. Not even every ionic compound. Most ionic compounds are soluble in water, but not all of them. And so if I look at the difference between sodium chloride and silver chloride, you can see that there's a huge difference. Sodium chloride has very high solubility. We can get a ton of it to dissolve in just a little bit of water. But silver chloride, it barely dissolves at all. So it's actually considered insoluble. And then our driving thing here when we are making a solution, like dissolves like. We need similar intermolecular forces in order to get the dissolution and the formation of a solution to happen. Okay? And so we can see here, we'll get ion dipole forces, hydrogen bonds, dipole-dipole forces, ion-induced dipoles, where an ion is what causes the polarizability of that cloud, a dipole-induced dipole, or our dispersion forces. And so all of these intermolecular forces are very crucial to making a solution happen. If we put things together that don't have similar forces, they're not going to dissolve. And so we need to keep those intermolecular forces in mind as we look at solutions.